So between switches and routers, I've just taken a quick break and made a massive brew. I feel like Network Chuck with his beard on this, but I know mine's not quite as impressive. But we'll move on to routing and router config in a sec. So moving on to routers, after I've just had a quick sip of my tea, we'll do the base config straight into SSH, setting the IP addresses, which is different on routers, then moving on to some of the actual real bits that make it a router instead of just a network device. So we'll talk about routing, we'll talk about redundancy and security based on this, and we'll also talk about modern networking. So we'll talk about NAT with regards to network address translation, and we'll get that set up as well. Exciting times. Cool. So we're just going to quickly bash out the base config, very similar to what we did for switches earlier. It's following most of the best Cisco security practices, and I'll just highlight the key differences, but I'll just sort of start typing away anyway. Hostname, VLAN RTR, and also the bit that I forgot earlier that we demonstrated was no IP domain lookup. A little bit different this time on a router for no IP domain lookup, because you might actually want to use this router as for NAT and also DNS lookups to pass that traffic. So whilst configuring it, I'd set up no IP domain lookup, but also sort of restrict yourself from doing that in real world once it's a production environment device. Service password encryption to secure the clear text passwords below with type 7 encryption, and then enable secret password, which password is the password. Very bad, I know, but we're encrypting it. We're not encrypting it, we're hashing it with MD5 for this one. Username, user, password, very bad, but anyway, this is just for the train environment. If I was to make this real post production environment, I'll then go through ensuring changing all the usernames and passwords to more complex, especially being that with the enable secret password, it encrypts it, but still that can be run against a rainbow table quite easily online, and something that simple or that common will be matched. Cool. Username and password for the SSH connections and the line con 0, so the console connections. Line con 0. Login local to say use the username and password we just set above. So log in local. Obviously we could have put password in earlier, but we don't want to do that as part of this configuration. We want to use the username and password for each of the telnet and or SSH connections and the console. So exec timeout. 4 space 0, so that's 4 minutes 0 seconds, which 0 space 0, which you see on a lot of demos, is bad for security. I know we're not being the most secure on here, but at the minute having a timeout for your session is good. Login synchronous for the user experience to copy and paste your line down. Quickly going into line VTY 0 space 4. Again, same as we did on the switch. Line VTY 0 space 4. Configuring the first 4 lines. Transport input SSH. Transport output none. So we don't want to use this device as a transitive device to others to stop pivoting almost. Login local. I'm just quickly getting through the base config just so we can set this up, and I'll show you the differences. We've done more or less that, so do show run, just check our config. So it's a little bit lacking at the minute. Service password encryption turned on. We've got a hashed enable password. We've got an encrypted username password. No IP domain lookup. Spanning trees turned on. Interestingly, on the router, which predominantly is a layer 2 anti-loop technology. We've got gig 01, gig 02, gig 03. We've got 2 serial ports and some fast Ethernet, and as well VLAN 1. So this obviously is enabled. We can set this up for doing some with the additional ports. We can set this up as a switch as well. It's got CDP running. It's what we covered again with the switches, and we've configured our line con 0 and line VTY0, so it's 4. The additional port that routers have is line AUX 0, so we need to turn off access to that as a security necessity, really. So I'm just going to stick it in here, line AUX 0. So line AUX 0 is the old 56k modem connection. And also, in real world, if you go up with a serial connection and plug into it, you can also use it as a serial port, so you can actually configure it. And often, that's a security weakness physically. If you can gain access to it, you can probably connect to it and straight away unauthenticate access into your router. Then you can effectively own that device if you know the enable password. So line AUX 0 transport input none. Oh, let's have a look. Transport output. Cool. Transport output none. Let's have a look what other commands are available. So we want to turn off access to this. So no login. That's better. Yeah. So cool. So that's going to prevent people logging into that device. We've ran our show run where we saw everything and we highlighted our line AUX. Let's start configuring IP addresses on it now. So what we're going to configure is our default gateway for our LAN initially. So that's the gig 00. Just to prove this, so it sits here on our gig 00. And as soon as we go no shut, we should see the green lights appear on that bit. So int gig 0/0 in global configuration mode, going into sub configuration mode. IP address on 192.168.1.254, 255.255.255.0. No shut. And I would like to say this is going to work, but it's not. And I'll tell you one reason why. So it's gone green, and it's good it's gone green. And if on this PC, for example, if I go desktop, go to command prompt, if I go ping 192.168.1.100, first one drops in with the second, hopefully. Yes. So we're sitting on the same network. So 1.254 is our default gateway, and that's not going to work. And if you're thinking it's because of the VLANs, you're perfectly right. So setting up our gig 00 with 192.168.1.254 is a standard configuration for a port, but one of the extensions we're going to talk about to this port is Inter-Vlan routing. And because we're not using the default VLAN 1, and if we'd set it up on the gig 0/0 as the IP address, which we have done, and we were using VLAN 1, it would just drop in and it would work. But because we're not using VLAN 1, we're using VLAN 10, we have to do a little bit more configuration on that gig port to get it to work. And we'll be doing that in a minute. We're going to quickly set up our serial port. We're going to set up our SSH to make our router secure. Then we're going to get our router working, so we can actually connect to it remotely and configure this Inter-Vlan routing, or also known as router on a stick, to get this ping working and also to get our SSH working. Cool. So what we'll do is jump back onto our router. Let's set up our serial port. So our serial port is serial 0/2/0. What's interesting about serial ports are, it's a very old technology, but also it's the way technology still works. So we don't often use serial ports. Serial ports are a lot older technology, but the technology behind it, such as what we can see on the left-hand side, such as PPP and CHAP, is still used. So we still use these, and serial ports mainly work on layer 2, even though we have an IP address. We still use this PPP encapsulation, or HDLC, which is the default high capacity data link, or point-to-point protocol, Point-to-point protocol is Cisco proprietary. HDLC is the open source. Is vendor neutral or IEEE standard. And the CHAP bit is the authentication. So that's what the PPP allows us to do the CHAP, which is Challenge Authentication Protocol. And basically it uses a password to authenticate between the lines, and we need to set up Route 2 for exactly the same as well. So we'll go through the commands and we'll talk about it, but basically this is how ISPs are used with all the way up to your BT or your Virgin Home Hub and your Sky connection. So it uses HDLC or PPP, and it also uses a password for authentication up to it, and it's and mainly, even though you're going out over IP addressing, it's also layer 2 protocol PPP and HDLC. So you're communicating to an endpoint through to your ISP on layer 2 predominantly. Cool. And that was the exciting bit of serial ports. So we'll quickly int serial 0/0 2/0. We'll quickly set this up. IP address 22.22.22.1 255.255.255.252/30, so it's a point-to-point connection, and that's using a public IP address space. No shut to open it up, and also what we can do is control the speed of it, and the way we control the speed is the clock rate. So clock rate 128.123. So that's the fastest clock rate available for a serial port. It's much higher nowadays, but basically you only set the clock rate on the DCE connection. And I'll just describe what that is. If I'm the command down here is show controllers serial 000. So I'm going to do show controllers serial 0/2/0, and what we can see here is DCE clock. So we've got the clock. When you, depending on the cable being attached and the direction of flow of traffic, one end will be able to set the speed. Normally the ISP will be the DCE. This time we're the DCE. So within our LAN we've set the clock rate. Obviously it's the case of it's what you pay for, isn't it? So when you're paying your monthly subscription or your 100 gigabit uplink, that's where they set the clock speed for us nowadays. So that's something to check. There is lots of information behind this. Lots of stuff that I don't understand. It's above my knowledge actually. So we set the clock rate. We've said no shut. We're currently using HDLC connection, which allows us to do a few bits. Doesn't really allow us to do much. So if I do show run, hold on, show interface. Do show interface. HDLC, does anyone see it? Connected, so it's up because the other side's up. And HDLC, high data link connection. So we want to change that. This HDLC doesn't allow for password authentication between the two, or password handshakes between the two connections, and that's what we want. We want that secure, not necessarily encrypted, the connection, but we want that to be secure and authenticated so we know who we're connecting to correctly. And there's two versions, there's PAP and there's CHAP. CHAP encrypts the username and password, whereas PAP passes the username and password in clear text, which is not good. So that's why we're choosing PAP. You can also have PAP as a primary, you can have CHAP as a primary, PAP as a secondary, and on CHAP PAP. But basically I'll show you in the configuration. So we're going to change that to PPP, point-to-point connection, point-to-point protocol, which is a layer 2 protocol. And we're also going to set this authentication off. Cool. So encapsulation PPP. So it's gone down because the other side hasn't been set to PPP, and that's why we've lost connection. So if I do show IP int brief, our serial connection 0/2/0 IP address the status is up but the protocol's down, because at the minute we're speaking on two different protocols. One's HDLC, the other side, and we're talking on PPP, which is Cisco proprietary. I'm going to add in the authentication, PPP, authentication. I'm just going to have a quick look. So PAP is password authentication protocol, and challenge handshake authentication protocol. Sorry, I missed out handshake. But it was CH for challenge. But you can. What's quite interesting is you can have chat PAP. So you can have chat primary, and if chat fails, you can go for PAP. It's just multiple levels of hack, but it's all happening. So I'm going to stick with chat anyway. And what chat does, it uses a username and password, which is pre-loaded into the router. And what I'm going to do is use this setup. So we need to know what we're connected to and have a shared and agreed password with that. And without me looking on the other side, and I know the other side has got CDP set up. So if I quickly go do show CDP neighbor, CDP, NEI, CDP is not enabled. Oh, exit. CDP run. Show CDP neighbor. Show CDP neighbor. Okay, so actually the neighbor's not running CDP, and this router's got CDP turned off by default. Just going to quickly have a look at this router setup, see what it's called, just to verify. Corp router, and we're going to add a username and password within here and set this up for chat PAP quickly. So enable conf t int serial 0 up do show IP int brief, see the IP address. So we've got 22.22.22.2 on 0/2/0. So it's already got the IP address set up. We just need to go encapsulation PPP, PPP authentication, chat, and we're going to add the username of our router into here. Exit, because it's got to be done in global configuration mode. So username LAN router, password, funnily enough, password. So that is our agreed and shared, pre-shared password. I'm going to go back onto our router and do show IP int brief. Show IP int brief. We're still so we're still up down because of this. Even though it's PPP now, we haven't got the agreed password. But if I go username, go to configuration mode, username, corp router, hopefully that should pop up in a sec. So do show IP int brief. Up down still, up down. Is it negotiating? Green and green. Oh, we might have an issue here. So this is our first aspect of troubleshooting. So do show IP, do show run. So we've got our two usernames, corp, CORP, router, password, which is password, and then we go to our serial port, PPP authentication chat, 252.222.221. Cool. Let's check the other side. Oh, has that just changed state to up? Do show IP in brief. Just might take a little minute to drop in, that's all. That's up, and let me check the side. up, down. Interesting. Shut, no shut. Try that. Try kick it in. There we go. Up, up. Good. It wasn't up before, was it? No, it was up, down before. So it took a reset to that port to then authenticate. Just going to take out the password and the username that we previously set, just to see if it drops the connection, really. So it will unauthenticate it. Exit, because it's in global configuration mode, so no username. And it was CORP RTR. It's still up. So it's still up. I'm going to go shut, no shut, just to give it a reset. Int 00/shut. No shut. I'm hoping that's going to go up, down. Do show IP int. And I think it is, because it didn't say the protocol has gone up. Yeah, so it's up, down at the minute, because the chat authentication is failing because we haven't got the username or password pre-agreed in my root config. So if I go exit, username, cool. It was just a little experiment that into serial 0/2/0 shut, no shut, and the protocol should go up, as we can see there. So change state to up, and do show IP int brief, and it's up. Brill. So that's done protocol and authentication. So that's currently agreeing. There is ways we can observe that, just to go a little bit more in depth, because as much as we want to see it and we get the username of the other router and the agreed password, debug PPP. I think it's authentication. So I'm just gonna open and shut the serial port again, and this debug, what it does, it prompts information on the screen, whereas our sort of connection here isn't actually very active, but it will give us prompts based on what's happening. So if I go /2/0 shut, no shut, we should see, here we go, we see it kicking off the authentication with regards to the chat for the serial port. So it's sending it sent, and it's acknowledged it. So do show IP int brief, and that should be up. Yeah. So I'm going to turn the debugging off, but basically what we've seen there is the PPP authentication handshake as well as the chat handshake. So if I go into global configuration mode and privileged user mode and go no debug PPP authentication, cool. So we turn it off, so we won't be bothered with the prompts anymore. And I'm just going to add in as an observation here is within privileged user mode, if we go debug PPP, we can see that handshake going on. It requires shut, no shut on port. Well, so we've covered off configuration of the gig port, which didn't work because we're currently using VLAN 10, and we're going to configure into VLAN routing. We've configured serial port setup and chat authentication and the clock rate for that. We're going to quickly set up SSH as we did on the switch earlier, and use version 2 because version 1.9 has got vulnerabilities. And then we're going to use Inter-Vlan routing and set up this router on a stick to get our client speaking to their own default gateway, so again they can get out to the web servers within that build. So we've set up serial port, serial 2/0. We've set up gig 0/0, but what we need to do is set up what's known as subports here, and that's our Inter-Vlan routing. But first, let's go for our SSH setup. So as before, get into global configuration mode, and we need our we've got our username already set up from the base config. We need our IP domain name, which is used in the RSA key generation. IP domain name -name lan.local, and that can correspond to whatever domain you're putting on at the time. Doesn't have to be .local. Crypto key generate. And as I said, real kit, there is other options available, Diffie Hellman, things like that, but we can only use RSA at the minute. 1024 is a good standard, so we can actually use SSH version 2. 512 is quite low, and actually, would you believe it or not, some countries don't allow anything above 1024 level of encryption. So we've set that out, and then if I do IP SSH version 2, as we set up there, so we've got SSH set up. I'm going to make sure within our line VTY, which is our virtual teletype lines, that we've got SSH enabled, so we can actually connect into it, and we're going to quickly prove it as well. So line VTY, jumping straight into it, 0/4, transport, input, SSH. Cool, so we're now fully set up for SSH, instead of the default of telnet. Right, cool. So at the minute we can't ping our default gateway, so we won't be able to SSH into it. I'm going to put permanent ping on from client 1, so when we can see it literally drop in, and then we'll set up this Inter-Vlan routing with the sub interface, and we'll put an IP address on, almost a virtual interface and a sub interface based on its different encapsulation. I'll explain that a little bit further in a second. Cool. So client 1, command prompt, let's get it. So ping 192.168.1.100, so that should work, which is the switch. Then .254 is its default gateway. I don't know if you can do permanent pings on this. Yes, you can. Cool. It's quite funny about where you put the arguments. So that's failing. We'll leave that running in the background, and we'll watch that drop in just as soon as we've configured our sub interfaces. So this is very much a standard across every network device which is a router. This Inter-Vlan routing is 802.1q encapsulation, and what we're going to do is set up the gigabit port with an IP address but on a sub interface. And with regards to this, we're using VLAN 10 in our switch, and we're going to match the VLAN number here and here, so it sort of corresponds. So what if we're playing with VLAN 50, for example, we can use .1q50 to match the VLAN number. So we'll just do that across, and we need to take off the IP address of our gig 0/0 at the minute. So let's verify what we've got set up first. So do show IP int brief. So we've got an IP address set on our gig 00. So it's our gig 00 we need to set up, but we need to take the IP address off and set up the sub interfaces. And one of the key things is the no shuts, because routers all come closed and require configuration to open them up. We need to configure we need to go int gig 0/0, no shut, and then configure our sub interfaces. So int gig 0/0. It's already open, so we don't need to go no shut, but for training purposes, I'm going to go no shut. We'd normally see it go protocol has changed to up. I'm going to take off the IP address we previously set, so I'm just going to go no IP address. So we're taking off the IP address. Do show IP int brief. We can see the IP address has now disappeared, and it's up because it's connected to our switch. Then we go into gig 0/0.10. So we've almost created a sub-interface under this one. We can apply as many IP addresses as we want, but each IP address needs to be applied to a subport. We need to direct it to say what type of encryption, what type of encapsulation it's using, because there is different types. I'll quickly show you this. Encapsulation. So we're using .1q. There are other options. So there's ISL, which used to be a Cisco proprietary encapsulation protocol for VLANs. It's a little bit more effective than .1q because it's the way it encapsulates it from the whole packet, not just the traffic and leaving the source and destination IP address. But cool. So we're selecting .1q, which is encapsulation.802.1q, and then we're matching it with the VLAN number. So just quickly, question mark that. So VLAN number, we can do 1 to 44,094. So we're choosing VLAN 10. We're quite effective with our VLAN numbers. And then setting the IP address on that. IP address 192.168.1.254 and followed by subnet mask. Obviously, with Cisco, it doesn't let us do the slash notation of the CIDR. But as soon as I hit enter on this, I'm going to quickly move back to the client to watch the ping drop in. So we've hit enter on that, it should have taken place. Quickly get on that, and we can see the ping's now dropped in, which is good. So it actually now the switch is labeling our traffic with VLAN 10, and now instead of hitting the gig port, the gig 00, it's hitting the gig subport, which is gig 0/0.10, an encapsulation for VLAN 10. So we're actually passing traffic now. If we were using VLAN 50, for example, I'm just going to show you its configuration. So what we'd set up is VLAN 50, and obviously you'd have to have a different network address because each port on a router is effectively its own network. So every subport on a network on a router has to have its own network. To verify this, we'll close this off. Back on the router to verify what's going on. There we go. There we are. Cool. Just to verify what's going on, do show int brief, and we can see here we've got gig 00 is open and up, and no IP address assigned because that would be VLAN 1, which is the default VLAN, and we've got VLAN 10 subport 10 192.168.1.254, which is up. I'm just going to shut the physical port and show you the effect of what happens on traffic, and we're going to leave this one up. So if I go int gig 0/0 shut, do show IP int brief, so we can see it there. The subport has changed state to down, but the gig 00 has changed state to administratively down. So we can see they've both now gone administratively down, and our traffic from client 1 has died. Cool. So we're looking good there. So we need to change that back to up, and we can make that happen. So that's obviously we close the physical port, not the virtual or the sub port, and you can see the effect on it, what it's done on the actual diagram itself. So I'm just going to go no shut. Cool. So we're all cooking on gas. So ping, do ping. Oh, pint. Not working yet. 192.168.1.1. So we can ping down, and you can see there difference between the way Windows and the Cisco device works, whereas it's sort of similar to Linux. It's got the exclamation marks, and if it's not entirely right, you'll get dots instead of the exclamation marks. Cool for the ping. Whereas Linux, you have to stop the ping happening instead of space -T. So we configured router on a stick with the subports to interact with VLANs. We configured SSH. We configured the serial ports with PPP and authentication, and we've done our base configuration on the router. Very similar to what we've done already on the switch. Next, we're going to move on to routing. So we've got a few different types of routing. We're going to talk about, first of all, static routes, and we're also going to talk about administrative distances and cost. We're going to talk about default routes, and then we're going to go on to dynamic routing protocols, and we're going to quickly set up, just so you can say you've done it, we're going to set up VRrp, Ospf, and Eigrp. They both work differently. One is distance vector, one is open shortest path first, and one's a hybrid distance vector, which is Eigrp, Enhanced Integrated Gateway Routing Protocol. These are all internal. So I'm just going to add the word internal here because it's quite important. Internal. It's quite important to know that the fact that these are all internal routing protocols, and really the only external dynamic routing protocol is BGP, and that's what the internet uses. So before we start, we can see the command here, show IP route. When we talk about routing, it's the most important command. And this is based on, this is effectively what the router looks at. It looks at its routing table and makes the decisions based on that. So show IP route. And we can see within this breakdown of all the codes and how it identifies what networks are what. So we've got D is Eigrp, which we'll be configuring later. We've got E is external Eigrp, O is Ospf, R is VRrp, and there's a couple of different versions of VRrp. We've got B is BGP, if we're going to connect this to as like an edge gateway for internet. We've got L for local, C for connected, and then S for static. So each of these have a different cost, and we can see the cost. Not here yet. So we can see it breaks down 192.168.1.0/24. So that's our network, and it's directly connected to it through the subnet. And it says to get to this 192.168.1.0/24 network, use gig 0/0.10, and to get to the 22 network, 222222 is the public IP address scheme. To get to the network /30, use 0/0/2/0. So even though we've not configured any routing, we've configured the interface and it's already building up its own routing table. We're going to see this populate quite a lot in a minute because the other router we've got has got some network advertisements that's set up through loopbacks. So what we're going to do is set up this router. First of all, to do static route directly across, which has got an administrative distance of 1. So what that means is the lowest number always wins within regards to routing. So it's about the cost. So with this static route, I'll demonstrate it here quickly. There's two ways of doing it. We've got chucking it out of the exit interface. So IP route, the network address to say what we're connected to. So we sell what we're connected to. We say, oh, correction. For dynamic routing protocols, we say what we're connected to. For static routing protocols, we say how to get there. So we want to access the 192.168.20.0 network, which is the Corp network here. So this is the 192.168.20.0 network. And to do that, you've got to exit via serial 000, but in our case it's 020. Or what you can do is the next hop IP, which the next hop IP is 222222.2. So that's serial 020 over here. Cool. I'll demonstrate one way only. I'll demonstrate the next hop IP because it shows a little bit more technical knowledge, but also if, for example, the interfaces were to change, and I was to change the, I was to move this serial connection to 0/2/1, then that static route would still remain the same because it's the next hop. It's not based on which interface do I chuck it out of. Cool. So let's do it. So within global configuration mode, IP route 192.168.20.0, 255.255.255.0, and then next hop IP 222222.2. Done. So we've got our static route. If I do show IP route, we can see static route here, and this one means cost. So that we'll see that cost change later. Dynamic routing protocols tend to have higher costs, and we've got something here. This additional bit within the nodes is a floating static route, and what we can have is almost like a standby route. Just in case that fails, we can have a second port out that can reach it, and that's what's demonstrated by the 2. So what it does is changes the administrative distance, which is the cost, or the how much do I trust this network advertisement. And what we do is we say 2 to increase the value from administrative distance by default as 1, but we change it to 2. So then it becomes a floating static route, or very much a reserve. So we can see it there, change the route. And obviously, as I said earlier, these documents will be available after the lesson. So I'm not going to put that in because there's no need, but also I can just show you, if I do question mark here, distance, we can change whatever static route administrative distance value to anything between 1 and 255. Cool. That's why the question marks are really good for to see what else is available. So we've seen the routing table, we've seen static route, and at the minute we're going to see how far we can ping along the line and just see how far we can get without setting up the other side particularly. This is quite poignant and quite interesting. So gateway of last resort not set. This exists on Linux and Windows itself as well. So this is what's known as a default route. And it's basically, if I don't know about it, where do I chuck it? And generally, Windows machines and Linux machines have got that set up as their default gateway. And that's where they're going to pass that traffic. So if you're going to think about anything, this is our default gateway for our router. And where are we going to chuck our traffic we don't know about, or that's outside of our network, that's not been advertised. Brilliant. So back to our client, just to see how far we can ping. And then we're also going to do trace route as well. So ping 192.168.1.2, just see if we can ping another client. So that's within the same VLAN 10. Let's see if we can ping 3. Yeah, good. So we're already pinging our infrastructure. 100 for our switch. Yep. 254. Yep, that's dropped in as well. Cool. And interesting. 2 seconds. What you can see here is the values are changing. So something to keep notice and probably make it more cyber related. TTLs and getting pattern, understanding the fingerprint of different operating systems. So key bit here is Packet Tracer is actually quite intelligent to give the default TTLs based on the operating system. So 128 is a Windows TTL, whereas a 255 is a Cisco operating system. So as we're pinging along, even within this Packet Tracer software, we're seeing it identifying, it's sort of fingerprinting the operating system. So ping 192.168.1.1 to 128. If I go 100, which is the router, 255. If I go 254, which is our default gateway, which is the router, 255. And let's see if we can ping the outside IP address of our network. So it's the 22.22.22.1, which is directly connected to our router. Yeah, cool. Let's see if we can ping to the other side. No, and the reason we can't is because the other router yet isn't advertising that network to us, that actual connection. So as soon as that comes up, this will drop in. So I'm just going to add a TAC-T again to that, just to see when that drops in. Minimize that. Let's get on the other router. And there's different trains of thought. So static routes are very good for being specific about what traffic you want to send over and what direction. And necessarily, they're high administration, but high in security as well. Whereas dynamic routing protocols are low in administration, but lower in security really, because if you're advertised the wrong network, for example, and it's quite easy to do so, you can send out a lot more traffic than you'd want to. and it would do it automatically, really. So I'm just going to quickly configure the return static route for this network. IP route 192.168.1.0, so we're trying to get back to our home LAN. And we can either go via the exit interface or the next hop. So 22.22.22.1. Cool. So do show IP route just to check what we've done. Static route. Yeah, returning traffic. And let's go back to our client here. That ping's dropped in, which is good. And see if we can ping all the way around to the web server, just to see what the web server's IP address is quickly. Oh, 100. So we've actually advertised to the wrong network. We've requested to get to the wrong network. So if we try ping 100.2, this won't work because we've done IP route to the wrong network. 192.168.100.2 destination host unreachable, because we've done the static route to the wrong network. So it's quite easily fixable, and that's why it's quite good to do these live demonstrations. So we've been kicked out, and these are our passwords. It's good to see that what we've previously set up in our base config. So EN and password there. One thing I've not set up within this router is the banner that we did within the switch, but it's quite easy to set up. I can copy and paste the config in. But so do show run. What we want to do is see the static route and take it out, or correct it at least. So there's our subport setup. There's our serial port, and our routing should be just below the ports. Here we go. Cool. IP route 192.168.20.0, so that needs to be 100.0. So if I can say no, IP route to take it out, 192.168.20.0, and you've got to do the full thing. And then we can just put it all back in very quickly just by pressing the up arrow. 100. Here we go. So now that static route's in, and can this ping? Yeah, and it's in. So it's pinging all the way along. If we wanted to be more specific, if we wanted to ping a single client compared to another one, and only allow access for this LAN to connect to the domain controller and not the web server, for example, so we wanted it to access this server and not this one, this one's 100.1 and this one's 100.2, we would simply change the subnet mask from 255.255.250 to all the 255s to say it's an indefinite /32 network. We'll quickly do that now just to demonstrate the sort of powers of this routing itself. So I'm just going to take this out. So we're going to say no to that, copy, paste. So we said no to that, and what we're going to do is allow it access to one IP address only. We're going to say .1 and 255 there. So that's indefinitely saying this IP address because it's a /32, whereas we're not opening it to the network, we're opening it to the single IP address. Cool. So now back on this client, if I go ping 192.168.100.1, in, obviously the first one drops because of the ARP process. .2 should be unreachable, which is really good, and that's how we can control static routes. And depending on, you can really refinely permit access into different networks, and that's why static routes are really good, providing you can understand them and break them down. So making sure you understand the network addresses or single IP address, making sure you understand the exit interface or the next hop IP. What we're going to do is basically eliminate all of that good security that we've got and just have a default route out and chuck all our traffic out of the serial port as well, so we're not even really going to control it, and we're going to see what we can reach from there. So we're going to take out our static route. We're going to undo all the good work we did, so no do show IP route. That's verifying. There's no static routes in there. So if I now go IP route 0.0.0.0, any network of any subnet mask, I'm sort of shivering typing this in, serial 0/2/0, because this is opening up our entire network and allowing us to access anything, so it's bad, it's very naughty. So our gateway of last resort is now going to be set. So hit enter on that default gateway. This is not a point-to-point, may active. This may affect changes. So if I go do show IP route, our gateway of last resort is now set, and it's going to be chucking it out of our serial 020 static route. Brill. Let's get to our client. I'll go to a different one this time just to prove the ease of it. Ping 192.168.1.254, so that's our default gateway. 22. Bro, so we're seeing our private IP address 192.168.100.1. Yep, seeing that. 2. Yep, seeing that. And let's go for the switch. Might be 200. Might not have an IP address on. But anyway, we can get right into the network, and that's just through a default route, and it doesn't provide a lot of security with regards to that. Generally, the only time you'll use a default route on a router is through a NATed interface and your connection to the internet. So you will chuck it out through that default route, and then you'll allow the ISP or your router to do the BGP routing. Cool. So what we're going to do quickly now is take off the default route and then set up VRrp, Ospf, and Eigrp in that order between the two. And I'll describe the routing, what happens between them, and the differences between them. Cool. And at least then you can say, with regards to a networking lesson, you've done all 3 major routing protocols that I've discussed, because it's quite often you'll hear the difference between them, or you'll hear them but not know the difference. So I'm just going to take off the static route. So no IP route. Seeing how much I can not type and get away with do show IP route. So the gateway of last resort is not set, so that's the static route taken out. So now we're going to do VRrp, which is basically a distance vector routing protocol. It comes in 2 versions, version 1 and version 2. Funny enough, actually version 3 as well. So version 1 didn't do subnetted addresses, so at the minute we're using class-full IP addressing, but what we did in part 1 was talk about subnetting, so it couldn't cope with that. Version 2 does subnetting. Version 3 is IPv6, and we will get onto IPv6 practically in a bit of a routing exercise. It's really easy to set up, and we do talk about it a bit further on with regards to this notes. So once we've done NAT and ACLs, we've got a bit of IPv6 for us, just to configure an interface with IPv6 and set up the routing between. It'll take 2 minutes, but it's actually quite good to have an activity on it, because then it allows growth of knowledge and a little bit of confidence, because even this lecture is based on IPv4, and most of them online are based on IPv4, but rarely do you get exposed to IPv6. So having an opportunity will quickly set it up and demonstrate it, and so you can see it and do it yourself. Right. So RIP. As I said, it's what's known as distance vector. So it is intelligent. It can choose which direction with regards to a network it's going to send the traffic, but it's based on the hop count. So whether I'm using a gigabit or a fast Ethernet connection, providing, let's say, if I've got 6 gigabits and 2 fast Ethernets, even though the gigabit might be quicker through the 6 connections, it will go for the fast Ethernet connection because there's only 2 hops. It does, for loop prevention, it's got a maximum hop count of 12, so it's not allowed to pass that point, and if it does, that's when it dies really, at that point. So we'll just quickly configure it for getting access to the other side. We do need to configure the other router as well with regards to that, so Conf-T, already in it, and then router RIP, just see if there's anything else. No, we can say version 2. Turning on version 2 allows us to use that subnetted network. So network, and all we want to say is we advertise the networks that we're connected to. So we're connected to 2 networks. So we go 192.168.1.0, and we can often, you can add in a wildcard as well within the next routing protocols. We'll add in wildcards. I'll describe them in a minute. And then we're also connected to the 22 network, but that is that's a point-to-point network. So I want to be quite specific what our network address is in with that. So I go network. Oh. Cool. So that's our network address. And then what we have to do is set that up on the other side. I'm just going to go do show router RIP. Router. Might be IP. Yeah, sorry, it is. Show IP route. I'll come out of that. I'll go into privileged user mode. Show router. Show IP RIP. Oh. Show. There we go. Right. Show IP route RIP. Cool. That'll be the command. Once we've got connection to the side, that will be our command that we're going to run to check the status of our RIP. Put on a permanent ping to the side quickly, just to prove our connection. So, can we ping the other side? We shouldn't be able to. Nope. Unreachable. 1. Unreachable. Put on a permanent ping there just to see it drop in. And that'll be the sort of last ping I run really, because we'll leave that running in the background. So I'm just going to leave that there running. Configure this RIP. Router RIP. So it's still got a return static route, which isn't going to return anything. I can take that out, but I'm not going to bother at this time. I'm going to go router RIP version 2, network 192.168.100.0 and 22.22.22.0, and instantly we hit that, RIP's communicating, and it's dropped it in. So it is dynamic. If we had a third router here, which we'll be doing as part of an exercise later as part of first hop redundancy protocol, we can see which direction the traffic's going. Cool. So that's RIP. Next one we're going to talk about and do is Ospf. Let's have a little look at our RIP setting. Router RIP, we can see there we've got router advertisement. So show IP route. We've got gateway last resort is not set, so it's not passing anything through the default route. We've got R, which is RIP, and administrative distance of 120, so that's quite high. We're going a little bit down on when we talk about Ospf, because I think that's 110, and then when we talk about Eigrp, that's 90. So it's got administrative distances a lot lower, and then it tells you how many hops. So that's only got one hop. Cool, and that's through 0000 to get to 192.168.100.0. So we'll take out our RIP. So we're already in privileged user mode, so no for enable. Conf T, no router RIP. So we're just taking that out. I'll leave this ping going, I think. So we can see the route and the pings just dropped to the side. And now I'm going to do quickly is set up Ospf and describe to you what Ospf does, how it's different, and also what a wildcard is, because that's the more interesting bit, and how it goes on. So Ospf is open shortest path first. It's a dynamic routing protocol, and it's not distance vector, which is like RIP, doesn't count the hops. It uses Dijkstra's calculations to work out the open shortest path first with regards to how it's going to do it. So there's a lot of different calculations that go into it. Cost and delay of the connection, also the distance of the number of hops effectively, as well as how fast convergence happens. So it bases a lot of calculations on that. Ospf version 1 was again class 4. We're now at version 2 with IPv4, and version 3 is IPv6. It uses Ospf version 2 by default, so there's no need to go with version 2. And we advertise the networks with the network address that we're connected to with a wildcard. So a wildcard is basically flipping the subnet mask. So if I have a subnet mask, for example, of a point-to-point connection, we basically take this away from 255. So our wildcard of a point-to-point connection, 3. So 3. So it's almost like the negative of subnet mask. And with Ospf, it's based in areas. So we, as a standard, 99.9% of the time, we use area 0. It's the backbone network. But what Ospf allows us to do is minimize routing traffic and take control of that, and say, okay, you're now area 1. And if, for example, you've got a network which isn't always up, which isn't always stable, you can separate it into a different area. That's also known as a stub network, and you can say that's area 1. But often what you need is that router, a single router, to be in area 0 and area 1, and they're often called an area border router. As I said, area 0 is the backbone. Outside of that, we do get into an extension to Ospf of what I've sort of just alluded to. Is called multi-area Ospf, of using this area 0 and area 1, or many different areas. Whereas in the first command to activate Ospf, router Ospf 1, this is called a process ID, and it only identifies the process. Whereas within the Eigrp, this 1 is called an autonomous system number. It's actually used within the calculations of the Eigrp, and that needs to remain the same. It's a standard SOP to use 1 as a process ID, but you can have 100 if you wanted to. And whatever is different on the other routers, it doesn't matter. But for Eigrp, they all have to be the same to be able to communicate, because it's part of the hello messages. Ospf does get into like lots of sub information. So we've got multi-access networks within Ospf, and we can see that. And there's what's known as designated routers and backup designated routers, and the way they take charge. And I'll probably talk about that as we go through. But first of all, let's get it set up just so we know what we're doing with it. So we haven't got Ospf set up on the other router yet, so it won't drop in. But let's quickly configure it. So router Ospf open shortest path first 1, which is the process ID. Can be different on any other router. network 192.168.1.0, so we're advertising what networks we're connected to. And what we're going to do is, you can get away with putting the subnet mask here, but what happens is Cisco is quite forgiving and will change it into a wildcard for us. So I'll do subnet mask here, and for the next network I'll do wildcard, and we'll see the difference. Area 0. And I'll also do network 22.22.22.0. 0.0.0.3 is wildcard for a point-to-point connection. Area 0. Oh, obviously you spell network right. Run. So now if I go do show run, we'll quickly inspect the Ospf. And routing always sits below the interfaces on here. Have you seen this? So we initially put in the subnet mask, but what Cisco did was change it into a wildcard for us. There is one thing to say about Ospf at the minute. So we're using serial connections. If we use gigabit connections and we start using Ethernet, we need to add in additional commands because to change the calculations of that, because it doesn't take into it, because it's a bit of an older technology, it doesn't understand what gigabit is. We're not going to do that yet because we're not playing with it, but there is additional commands to put in when working within Ethernet areas. Cool, so we've got that set up. We're going to quickly set this up on our other router. We can leave VRrp running, but because we're not running VRrp on the other side, you can see there that we're not getting any connection. So as soon as we set up Ospf, it'll talk and we'll get our connection. So conft router Ospf, and if we're working with, for example, if we were working with IPv6, it'll be v3 we put in, but router Ospf, then process number, which is 1. To prove a point, I'm going to do 2, just to prove it works with any process ID number. Process ID, I'm not American. Right, network 192.168.100.0 0.0.0.255 area 0. Then network 2.2.2.0 0.0.0.3, so that's the wildcard. Area 0. Honestly, the depth you can go with Ospf, yet again, helps if you spell the network right. You talk about, because this is a point-to-point connection, so the depth of Ospf, you can talk about multi-connections network, multi-Ethernet connections network, with regards to the to designated routers, and also the multi-area. You go on to not only from sort of what we're sort of talking about now as the CCNA level, you can take Ospf up to CCNP when you talk about your multi-area, which is, it's only a step forward. You literally change the number at the end, but then you can take it up to CCIE level with regards to authentication, and there are other things to set up. There's advanced configurations with regards to architecture, which I'll quickly show you. So we set up this, and hopefully within a few seconds, here we go. So as part of Ospf, they form neighbor adjacencies. So I'm going to quickly show you the show IP Ospf neighbors command, and our ping's dropped in. And also the something to notice here is, because it, let's say, core cyber skills course, knowing the TTL, because the TTL will reduce by 2 because our ping is going from the computer through one router and through another, so it's reducing it down by 2 from the standard 1 to 8. I'm just going to do it on here. So do show IP Ospf neighbor. So there is only one neighbor, and we've got full adjacency. There is different stages, the same as similar to spanning tree protocol. It will go through listening, negotiating, then full. And when we talk about like multi-access network, if we've got multi-routers in a fully meshed network, they will have different relationships depending on who's in charge. And there's something called the druther, which if you're interested in that, I may get onto that depending on what time we get onto Eigrp, and that's something that I might be able to fit in at the end. Bro, so that's Ospf. There's one thing we can add in to really configure these networks to make them more effective. So what we don't want to be doing is advertising network advertisements down here. So we don't want to be telling the switch and these clients about, like, look, I'm running Ospf and this is the networks I'm attached to, because A, for network efficiency, and also if you've got someone on network who's monitoring traffic and then suddenly you get Ospf advertisements through, it's not going to be amazing for that sort of traffic limitation piece. Network chuck. So back on our router, what I'm going to do is set up passive interface quickly underneath our interface, and this can be done with Ospf, Vrrp, and Eigrp to stop those network advertisements. So user. So what I want to do is stop network advertisements under the gig 00, and I'm doing it under the gig 00. It'll stop it also on the sub interfaces. So if I go into gig 0/0 passive, let's see what commands we can run. So it's Ospf IP maybe. Where is it? Where is it? No, global configuration mode. No, it's done. Sorry. Router Ospf 1. We do it actually under passive interface. Here we go. I thought we did it. So passive interface gig 0/0. It's done underneath the router RIP, so I'll add it in here. Note network passive hyphen interface, and we've used gig 0/1 in previous, or 00, it doesn't really matter. So we've now made that passive, so we're reducing traffic workload. This port coming down, it's being more intelligent, and that's part of sort of infrastructure and architecture management. As we said earlier, the things that you can really take control of is the way traffic goes round at layer 2 and layer 3. Cool. Right, so we've now done Ospf. Let's quickly do Eigrp, very similar. Let's take out the no router Ospf. And also, the ping worked, and it was using 2 different process IDs, which is good. So that proves the point there. No 1. Cool, so let's just check the pings dropped. Yeah. And now, router Eigrp, enhanced integrated gateway routing protocol, even though it's internal. Just a quick brief on it. So it's enhanced distance vector. So it uses what's known as K values, and it uses up to 7 of these to work out which is the quickest route. It used to be Cisco proprietary, but now it's an IEEE standard. It's got an RFC number basically, and that allows it to be used on any platforms, and it is. It's one of the more popular, but also it's not the popular. Ospf tends to be more popular with regards to commercial settings because it's been around longer and people tend to know it more. Whereas the Eigrp is sort of the unsung hero, as I like to think so. Cool. So it uses cost, and it also uses bandwidth to determine which path it's going to take. But there is no extra advertisements needed with regards to if it's on a gigabit or fast Ethernet link, it'll just take it and use that as part of the calculation. So router, Eigrp, and then this is the autonomous system number. So I'm going to go for 1. Network, and there's a couple of different ways we could do this. I'm going to go for 192.168.1.0 so that we're advertising what we're doing. And what we're doing, this is the class full point. I can do a question mark and say I could enter a wildcard, or I can just stick with that. And because we're using that as because we're using the class full network, I'm going to advertise it. If we didn't own that entire class full point, we need to then put a wildcard, but because we can get away with it. But because with 22 I don't own it all and don't want to be ruining other people's day, I'm going to add in the wildcard for this 0.0.0.3. Cool. We can do passive interface again. And we'll need to set it up on the other side for the pins dropping. 2 secs. So our neighbour relationship is down on on Ospf because we've chopped it off. So router Eigrp sounds like I'm going to do 2 and just prove the routing doesn't drop in, hopefully, and then I'll do 1. So network 192.168.100.0. Cool. So hopefully it doesn't drop in. I'm just going to wait for a few seconds because it took Ospf a few seconds to drop in, and it's still they have to send updates. Yeah, again, there's more theory behind that about hello, and they call it hello and dead time, about how they send messages to each other. Normally, with regards to both Eigrp and Ospf, default Ospf is set at a hello message every 1 second, and the dead time is set to 4 seconds. Eigrp is set much quicker, and that is something you can change as well with regards to the hello and down times to make that convergence and that agreement a lot quicker. So that's not talking to each other. So I'm just going to say no on the initial thing and make it Eigrp 1. And I did mention about multiple ways of doing it, and I'm going to be a little bit naughty here and show you basically the default root method of the Eigrp. You can do the same within Ospf, I didn't like typing that, but I just wanted to prove to you that you can oversell networks. So basically, you put in network 0.0.0.0 is saying whatever I've got, just advertise it, and yeah, it's very naughty that. So now that's created a dual network relationship. So dual is the algorithm used to a part of these k numbers to work out the algorithm and which route it's going to take. There is only one route because we're a point-to-point network. But from here we've got everything's dropped in. It's looking good. Let's do a couple of the show commands to verify. So what letter are we looking for on the routing table? And if you shout in D, hopefully I'm right. D Eigrp, and have we got any Ds? What is going on here? 2 secs. Let me expand this. Is this sending it back through the static link? Hold on. No. I'm going to take everything out. No IP routing. So that'll drop. Basically, the command IP routing, don't often use it, but IP routing, no IP routing turns it into a switch and turns off the IP routing functionality. So we should call, so show run, so that should get rid of, show run should get rid of all of our routing protocols, whatever we previously had in here. We've got a static route still there, so I'll take that out. No 192.168.1.0. I want to make sure it is Eigrp getting everything across. So do show IP route. Make sure there's no S's in there. So there's no S's in there. And whatever appears in here is the active route. So even though we had Eigrp set up, it was the active route of the static route sending it back because it's got a lower administrative distance. So, right, router Eigrp1 network, and I'm going to do the same again with the dodgiest root network advertisement in the world. Dual network relationship formed, pings up, do show IP route, and we should have a D. Cool, we've got D here. Network, so we've got administrative distance of 90, and the dual cost is 2.1. I'm not going to go into the maths of that. Good luck if you understand that. As I said, it's different K values within the dual algorithm. But then to get there, it's sending it via 22.22.22.1 as the next hop IP address, and out of that interface. Cool. We're looking good. Let's have a look at what specific Eigrp. There's show IP Eigrp topology, and this is how Ospf and Eigrp are different. Ospf only likes to inform you about its neighbours and what's connected it to what it's connected to, whereas Eigrp, trying not to sound like a farmer, wants to know about the entire topology. So if there's any other routers running Eigrp that it's not even directly connected to, but it's in the same autonomous system number, it will know about it. So it's a lot more process heavy. Glad I said process and not process. So see, I just want to do this in privileged user mode. Show IP Eigrp topology. Cool. Let's see. So there's a lot more behind this than I could tell you probably this time at night. There's something called feasible distance, which is about loop prevention, and there's a certain rule. Eigrp runs by a certain rule to prevent loops. So it basically says the successor cost has got to be less than the feasible distance or something like that, and it always runs by this rule to prevent these loops. There's successor and reasonable successor. So the reasonable successor is the router in charge effectively of sending these updates again. Cool. Right, we're there. Right, so that's routing as a whole. First hop redundancy protocol is going to set up a couple of minutes to set up like it did with the switches earlier. But what we're going to do is basically provide redundancy, not now only at layer 2 like we did with spanning tree protocol, but also at layer 3, and give multiple routers, but give it one IP address, which will be that virtual IP address. And there's, just like with any routing protocol as well, there's multiple different versions. So for first hop redundancy protocol, we've got Hslp, which is hot standby routing protocol. Vrrp, we've got GLPB, which is global load balancing protocol. GLPB, global load balancing protocol. I've got those two letters the wrong way around. BP. Cool. So just for own awareness, Hslp is Cisco proprietary. Vrrp is the open source IEEE version. GLPB, which is definitely the best, because it loads balances by default, whereas the other two we have to load balance by VLAN or Inter-Vlan routing support, but this one load balances by default. Brilliant. Right, I'll just get this quickly set up and we'll start. So I've just extended the lab to add an extra router in. I've added extra routing for Eigrp, what we were just doing, and now we're going to set up Hslp, which is hot standby routing protocol, which is a first hop redundancy protocol. It comes underneath the theme. And what it basically does, it allows 2 or more routers to act under the same IP address, and these are often called virtual IP addresses, and this virtual IP address is then the default gateway IP address set within the client. So I've got the 2 IP addresses. This one is still 192.168.1.254. I've set this one up as 192.168.1.253, so I'm just going to do show IP int brief. I've got 1.253 on subinterface of .10, which if you remember was because we're working with VLAN 10. I've got 44.44.44.1. That's up down at a minute, but I can work out why in a sec. So I'll get this up. I'll get the protocol up on the serial 000 at 0020 for this additional network. I'll get the Eigrp working, and then we'll set up Vrrp and Hslp for the virtual gateway. So I'm just going to quickly do show IP int brief. So some troubleshooting on serial interfaces is quite interesting. So I've got this one set up here, which is correct. I'm just going to go no shut and shut on it. 0 shut, and then no shut. So that's, I've done that on the wrong one, which is always good, especially if this was production. So shut, no shut. Often what stops serial ports working is port speeds. 128.0.0.0, so that's taken it. Do show run just to see our serial port set up. So we're both running. It's running PPP chap on one and HDLC on the other. I don't know if that's going to cause an issue or not. I'll see. Because I think it might. So I'm going to make everything PPP and chap. Encapsulation PPP, PPP authentication chap, and then do the same on the other side. Do show IP int brief. So that's still up down on serial 020. I'm just going to make that int 0.0/2/0 PPP encapsulation PPP authentication chap, and I haven't added the username in at the top either. So within global configuration mode, username is corp RTR and password is password, and I'll add in username. It was LAN RTR2, password in 0.0/2/1 shut, no shut. Do show IP int brief. Let's have a little look see. Yeah, no. Do show run. I reckon it might be some net mask. I might have been lazy and put a /24 in. 252. That's correct. It's open. That's not chat pack. That's not taking it. So I'll just quickly add that in. Int 0.0/2/1 encapsulation PPP authentication chap. And you can see it's fault finding is just a matter of rerunning some of the show commands and verify commands. So shut it shut, no shut, just to kick it off, and it looks like everything's dropped in because we've got a new adjacency 4444. So do show IP int brief. Yeah, so it was the fact that you can't have one serial interface on HDLC, which is the default, and the other one on PPP. So we've now got them both on PPP and chat, so they're both authenticated. They're both up, and now this new addition router should have exit, exit. Oh, user show IP route should have a couple of D's in it. So it's got a D for 22, which is good, and it's got a D for 100, so it can reach over to the side, which is good. I can even ping 192.168.100. Cool. So that's seeing the other side all the way through. Cool. Let's make sure. So at the minute, this is seeing the other side because it's passing traffic to .254. So IP config. Here we go. IP config 1.254, which is this IP address on here. If I just do cool. So we've got 254 set up on this interface in the gig 0/0. It's 253 on this one, on this subport. But what we want to do is have a virtual IP address of 252. So 254, 253 physical, virtual 252. So we want to set this computer up with .252 and then have Hsrp or Vrrp or Hslp then pick up and then send traffic across. So then we've actually got the first hop, redundancy because we've got two of them or more, protocol. So it's literally what it says in the tin. So I'm just going to change the IP address on this, change the default, change the there we go. Change the default gateway to 252 and exit on that. Double check it. Let's scroll up a bit. 252, so that's been changed, which is good. And can I ping out now? I don't think I will be able to. So that should fail because at the minute 252 doesn't exist anywhere on my network. But what we're going to do first is set up Hsrp. So Hsrp's pro word is standby. So I can have as many standby as I want, but instead of configuring this IP address on the physical, so you've got your physical IP address there, which we've already got. I'm going to set up this virtual IP address, and we're going to match this standby number to the same as our VLAN number and also our subport. So we need to set it up on both to get them speaking to each other, and we'll see standby 1, and we'll see which one takes control by going show standby, which is the verification command. So we'll start on our original router. We'll go enable conf t int gig 0/0. So if we were working with VLAN 1, we would need to go into there, but because we're working with VLAN 10, we've got to go into the subport. We've done the IP address we've got 254 on this one, so we need to put in the virtual, so we need to go standby 1, but if we were using VLAN 1, we'd use that, but to keep it nice and neat, we're going to use the VLAN number, IP address, this does it. IP address 192.168.1.252. Hold on. IP. Okay. 192.168.1.252. Cool. So it's not addressed there. So it's standby IP. Brilliant. So that's set up. There are different things we can also set up. We can set up preempt, so it basically waits a certain amount of time before it hands control back over. So if, for example, quite often with the network, you end up with something called a flapping port, and if a port goes up, down, up, down, up, down, and that is generally the in charge Hsrp main router, the active router, it will we've just seen it there, it's gone from standby to active because it's the only active Hsrp router, and the ping might have dropped in now as well. Preempts basically holds down, it's like a hold down time, and it's waiting for a defined amount of time before it will hand it over, instead of handing it over and going, oh, okay, now you're down again and taking it back. So it actually just waits. So now I think our ping might work now because because at the minute it's responding. And what it does, it just changes the ARP process really. So it falsifies to say that I own .252, but it just preempts it with a defined MAC address. So if I do ARP-A, this is, you used to have to know this for the CCNA exam. AC0A is the physical address for Hsrp. Honestly, amazing. Right, so we're going to set it up on the other one, and then we'll see which ones take control. And there is predefined rules of which one's generally in charge, so it's either based on default priority or highest active IP address on the router. So enable conf-t. We've got to set up our virtual IP address again. Int gig 0/0.10. Standby 10, because the standby number has to match both sides, otherwise it won't work. IP 192.168.1.252, and then we'll see the prompt come through to say it's either gone standby or active. What I'll do is I'll just stick that there and bring this one up. Right, oh, here we go. So that's now speaking to it, and it's gone to standby. Show standby. So this is in the standby state, and this one will be active. Show standby. So this is in the active state for group number 10. And the MAC address there we can identify as the active virtual MAC address. We've just confirmed it with ARP-A on the computer here. It's all very intelligent, it's all good. Preempts is disabled, as that's what I said the hold down bit was for. So the default priority is 100, and I think as before, the same with spine tree protocol, the lowest priority wins. We'll just give that a quick go. So I'm going to put the priority on here, or is it higher? Let me try 110. I think it actually might be higher on this. So if I go conf-t int gig 0/0.10 standby 10 priority, I'm going to go 10 there. I'm hoping this is going to take over. They've got to speak to each other first. It's not instant. It's based on hello messages, and these hello messages are sent every 1.3 seconds, which is good to know. Or it might not happen. I'm just going to shut this virtual port, shut my port, and reopen it. Int gig 0/0. What mode you in? Shut. No shut. And we'll see that one's become active in a minute as well, because you've got it shut. So we should see this one's now become active and no shut. And hold time timer, yep, so that's routing's now dropped as well. But new adjacency formed, so the routing's there, and now this router here on the right should say gone to standby. Gone to standby, and this one's now active. Well, it is active already. That's brilliant. So that's Hsrp, which has a active and a standby, and very much the same as Vrrp has an active and a standby. We can load balance with the only way we can load balance really with regards to these first hop redundancy protocols are through VLANs. So we can send the priority. So what we've done is change the priority for VLAN 10 on this one, and what we could do is change set it up for VLAN 20 on this one, and set this client up for VLAN 20, and set the priority as 110 on standby 20 on this one in the sub-interface of 20. So what that would do is send the traffic for its default gateway to the virtual IP address of this one, but it'd have to be a different network. It's the only way of working. As I said, there's many ways you can describe this, but yeah, we're only sort of scraping the surface with trying to do the entire CCNA exam topics in a night. Brilliant. Right, so next one, Vrrp. Or do I jump straight to GRPB? Vrrp, I'm going to jump straight to GRPB. I'm going to describe Vrrp and its only difference. So the difference between Hslp and Vrrp is the pro word is Vrrp and not standby. It again uses virtual interface, but also in addition to what Vrrp does, it allows you to use 2 IP addresses instead of 3. So whereas with Hslp we can use 2 physical and a virtual, with Vrrp we can use one of those physical. So we've got 2 physical at the minute. Without having Vrrp set up, we can actually designate one of these. It has to be the active router initially, but we can say active router, use your IP address as the virtual. So when that fails over, then the physical from the active then goes on to the standby. So that's the only difference. It's a bit tricky to set that up with using 2 if you're being really effective with your IP addressing. But it's again, priority is the same, and show Vrrp this time. So I'm just going to do show standby on here, so we can see the status of that. What we're going to do is take Hslp off and jump straight to GLPB, and then we can really start moving on, which is good. I know we've covered a lot this evening, so right. Conf t int gig 0/0.10. No standby. So that's how we take it off. No standby group number. Cool. I'll do that. I'll just set them both up. So I've got router 2 here and router 1 here. And so router 1 has now gone active on standby on Hslp. I'm just going to take this off. So int gig 0/0. I'm probably already in it, but I'd rather know where I am. So no standby 10. Cool. So now that's down. There is no Hslp anymore. We're going to set up GLPB, and what GLPB does, it automatically load balances for us. It's Cisco proprietary, but the addition it has an active virtual gateway, so it basically everything is active really, and it's based on whatever order it calls up. It'll go, well, I'm active, I'll do that one, I'll have that one, you could have that one. It basically has a bit of discussion about itself, which is good. So now I'm just going to quickly set that up. So it's very, very much the same setup. We can go into the interface, then we go GL balancing protocol number IP 192.168.1.252. Maybe I don't think Packet Tracer does GLPB. GL, nope. Let's have a look. So let's see what we can set up on Packet Tracer. So we can do standby. So underneath this sub interface, we can do standby. We can't do Vrrp, but we can do Hslp. Interesting. So actually, that demo has been missed. These are the commands for it. Very similar. So we can't even actually do Vrrp either on Packet Tracer. It's limiting. So, but Packet Tracer does get us up to the limits of what we need to know for the CCNA exam. Really, if you need above, we could have then set this up on a GNS3 environment, and it would have worked quite nicely. So next thing, what we're going to do is NAT. So we'll do NAT. We'll do a bit of disabling Cisco discovery protocols again. We'll do a bit of ACL work. and then go on to IPv6, and that'll be routers done. We'll chop back to the PowerPoint after that, make sure we're happy we've covered everything, then that'll be indexed. That'll be the lesson over. Brilliant. So, NAT, Network Address Translation. 3 different types: static, dynamic, or PAT, Port Address Translation, also called NAT overload, only because of the pro word used for overload. So what that saying is, static NAT is generally used for me coming outside, so me coming outside of the network to in the network more than inside to outside. So for example, if you've got an engineer, if there's a need for an engineer calling or something like that. Dynamic NAT is if you have a few IP addresses on the outside and then a few on the inside, and they're going to be like a pool either side, and they can dynamically associate with each other, or several outside and several out on the other side. Whereas port address translation can use one IP address inside, but as many IP addresses inside as we want, and it associates it then with the port number, and we're going to see that through, and we're going to see how significant that OSI layer 4 with the TCP with the port numbers actually are, because we can go, hopefully we can go net stat on here, net stat, we can go net stat on the client, see the port number for the access, and it uses that port number from the client in its own IP NAT translations database on the router. Cool, so we'll get that set up. It's really easy to be set up. So we need to, within NAT, or we're going to be setting up PAT, port address translation, we need to go onto the interfaces and declare which ones are outside and inside. And because we're using Inter-Vlan routing and the subports, we're going to stick that inside on both. Then we set up an access list to capture the traffic, to say what we want translated, and we want anything within the 192.168.1.0 network translated. Then we're going to pull in everything together and say whatever needs to be natted, stick it outside of 0.0.0, and then we're going to use a pro word overload at the end to translate it. We also may need a default route. I'll stick it here as default route, put question mark, and then if we do, then I can add it into the notes. It's just, at the minute I'm feeling a little bit itchy, there's no default route there, but we may need one. So what I'm going to do is use this router here, our original router, as the NAT router. So I'm going to take we've currently got these client 2 and 3 are set up with 254 on the I'm just going to delete that. Yes, cool. Right, now we're back to our normal configuration. These 2 clients set up with 254 as their default gateway, so still accessing this one. So I'm going to set up NAT here. So int gig 0/0 IP NAT inside. So this is an inside port. I'm going to do it on 10 as well, so I'll do .10 IP NAT inside. So at this point, if we're using any of the subports, we need to declare them as inside. And then what we do is we declare our serial port as the outside. So this is that would be the public IP address range outside of our private. So anything that's publicly owned, publicly routed, internet routable is what the term I was looking for. So int serial 0/0/0. Oh, no, int serial 0/2/0 IP NAT outside. IP NAT outside. Brilliant, so that's been declared. So now we need to set up the access list for the capture of the traffic. Access list, and we're going to be covering more on access lists in a minute, or later after this. Access list 100, so that makes it an extended access list. Permit and we're going to say permit, and the structure is source with a wildcard. So anything of 192.168.1.0 network going to any destination. So we want to capture any traffic that's heading out of this port anyway through routing, but make sure it gets translated. Whoop. And I need to say, is that IP? Yeah. So within extended IP addressing, you can do IP there, which is for the IP address range, or if it's specific IP addressed and translated, you do use the word host, but we'll show you that when we go through the question marks for access lists after this. It will only be a short demonstration anyway. So we pull everything together, IP net inside source list 100, so that's using that interface serial 0/2/0, and hold on, question mark, we can use the term overload and address translation, so we are overload, and what that does is changes it to port address translation instead of just dynamic net. Cool. So now if I go, what I'm going to do is get this client hook, and no, not this one, number 2, because it still can ping through. I'm going to go, I wonder if I can have multiple. No, I don't think I can. No, right, so ping 192.168.100.1, and then do that as tac T. So that should work. If not, we start investigating the Eigrp. .254, that's good. Ping 192.168.1.254. So this is like on the job troubleshooting. We can't ping .254 in a minute. Let's have a little look see. .254, that's correct. I wonder if it's got do show run. I wonder if it's got Hsrp set up on it because of the demo earlier. No? 192.168. 192.168. 1.254. 1.254. Doesn't work. Okay, so ping 192.168.1.254. Let's do a little bit of troubleshooting on this. So that's not reaching it. Do show IP into brief. So we've lost comms somewhere during this demo. So show run. So it's literally only to the LAN, so it's the connection between the switch and the router, or VLANs possibly. Let's have a look at the gate port, the actual lead one. IP net inside, IP net inside. Might 10. Can I ping 100? Was it 200? See if this PC can reach. Interesting. This is where we earn our money now, isn't it? Up 1.100. What has happened here? So it contains 1.100. 254. Let's see. Int gig. I'm going to close gig 0/2 first. Int gig 0/2 shut. Let's have a look at gig 0/1 because that could be an issue. No. T, no IP routing. See if it's something to do with this. I'm just gonna IP routing. Is this it? Got a funny feeling. I know. Good old reload. I did save it. Right. Could be the ARP table based on the earlier MAC address. So if I go restart, can I programs desktop? Ping 192.168.1.100 in 1.254 in. Right, it was just the ARP cache, I think, within the client. So that's pinging its default gateway. It won't be pinging the other side. So 100.1. So I'll put permanent ping on there. Unreachable because of the networking on here. So I'll just redo the networking. Well, I'll do a default route because that's how normally net would be accompanied with a default route. IP root 0.0.0.0, 0.0.0.0, too many zeros, serial 0/2/0. Cool, so that's chucking it out there. I'm going to do a default route back or a static route. Cool. And hopefully, so that's pinging now because it's 2 default routes back. And at the minute, there's no NAT. So what we need to do is IP NAT inside on int gig 0/0 IP NAT inside dot 10, then IP NAT inside, Control C, show IP NAT translations, and we're getting it. So we're getting ICMP traffic through. So that's our outside IP address, port number 58, using outside 58, 58, 60, 60. Let's get that. And then quickly, if I do netstat, no, that's because I've stopped it. Cool. So that's NAT ICMP being translated from this host. Oh, sorry. .3 is our inside, and that's we've got inside local, which is our computer IP address. We've got outside local, which is our endpoint IP address, which is our server. We've got our inside global, which is our 22.22.22.1, so that's our public IP address. We've got our outside global, which is our endpoint. Brilliant. There we go, that's NAT. 3 different types. We're using port address translation. CDP again. I love putting that in here, but obviously we saw earlier that it wasn't running CDP on this router. CDP run, then show CD. So we can't see anything. But one thing I want to prove to you is that Cisco devices are cross-pollination. So what I can see is the switch. I'm going to turn on CDP on switch. And then run this neighbours again, and we'll see how fast it populates. Maybe they need to talk, so I'll just quickly ping do 192.168.1.254. Yep, so they're both running CDP. Why aren't they picking each other up? Don't know. Move on, I think. So, ACLs, we've had a quick look at these with regards to traffic. So what I'm going to do is do an ACL. I'll do 2 ACLs or 1 just to block that client 3 from getting across to this one, to this router here. So I'll just put permanent ping on both just to prove. Ping 22.22.22.2. So that can ping it. So that's PC. This is the end one. Let's ping this one from it. So, oh no. So that's getting across as well. So those 2 are pinging. What? So those 2 are pinging now. What I'm going to do is set up an ACL to block traffic from this 192.168.1.3 client all the way through, really. So get my notes back up. Cool. And then we're on to quick look at IPv6, and then we're done. Brilliant. So there's two rules with regards to ACL. So ACLs is access control lists. You can have name or numbered, and with that we did numbered. With numbered, anything below 99 is a standard. Anything above 99, anything above 100 is an extended. With extended, you can put it down to a single IP or a host IP. You can also base it on protocol. So I'll just quickly show you on this router here. So if I set up an extended ACL numbered, so if I'm doing a numbered ACL, it's access list, then I can question mark my way through it. I can do standard or extended, so I'll do extended, and I've already got 100, I'll do 102 just in case. So then I want to permit, deny, or remark. One key note with ACLs is there's an implicit denial, which always exists within every setup. So you then permit, or if you're doing a deny statement, you must permit everything at the bottom, and I'll show you how to do that in a minute. So what we'll do is we're going to deny, through an extended ACL, we're going to deny 192.168.1.3 from accessing 22.22.22.22.2 only, but we'll let it access everything else. So what we want to do is question mark, so we want to deny, and we can do ICMP, IP, Ospf, TCP, UDP, or whatever. So because we're working with ping messages only at the minute, and ping doesn't fall under TCP, we want ICMP, and then we want source IP address 192.168.1.3, and then we want source wildcard. So this is its hold on. So what we can do, because we've not put in a specific host. So if we put the word host, we follow the single IP address host, and that's what we want. Host 192.168.1.3 question mark. Then we want it to anywhere, we want it to a specific single destination or destination network. So I would say we want a specific host, and we go 22.22.22.2. Then we finish it up. Done. And now we need to apply that ACL into a direction as well. So the rule of thumb, and I've got it here, is access lists. Access lists. So an extended ACL goes closest to the source, and the reason why that is it minimises traffic, because it minimises processing and worrying about NAT and things like that. So before it even hits NAT, we look at the flow of the direction. It's coming from this client, going to this IP address here, and it's going up here through the switch. We can apply ACLs to the switch, but we'll do it on the router. So literally, the 1.3 network is hitting this gig 00 and .10 subport inbound. So in. So what we want to do is apply it on the 0/0.10 in, and we'll do that now. So what we want to do is int gig 0/0.10, because that's the sub interface for this VLAN. Access list, hold on, is it IP access group 102, which is the number we used, and inbound, and hopefully you're setting that will stop this dropping in. Yeah, so that stopped and that was working. Is it? No. I know why. We've also, so we've done, this is what I mentioned about the implicit denial. So with every ACL statement, there's an implicit denial, which basically we've just blocked everyone else's traffic. Brilliant. Coming inbound. So we need to permit any based on this. So actually, this is a good learning point and actually getting on later. So what I'm going to do is get back into my router and add in this implicit permit now to negate the implicit denial. So back into the ACL 102, access list 102. So what we need to do is permit IP any, and this saying this IP will be any TCP, UDP, ICMP protocol. The minute we hit enter on that drops in, but the other one shouldn't. So that's still out. So this ACL is actually acting how we want, which is good. Cool. So that's numbered ACLs. I'll just quickly cover named, just as a bit of a freebie. So we want to do the same thing. What we want to do specifically now is we'll set a new IP address target, C, and Control C on this one. So we want to stop. Can access ping 192.168.100.1. So it's working, right? Cool. So we can still access across. So our NAT is going in and definitely being natted. 100.1. So we can get across there on both clients. So what we want to do is an access list named extended again to prevent these two from accessing this domain controller, because this shouldn't. So well, they should, but configuring anyway. So difference between named and numbered ACLs is the start. So for a named access list, we start with the word IP access list, and then question mark our way through. We're doing extended again. Extended. We always try to do extended because it makes it easier really to configure really what you want, and then it shows more control really. So word and name. So we want to stop DC. Then there's no more options for that. So we go enter, and then we're currently in. This is where it says what we are in. We're in extended named ACL. So we want to, from this, we can permit or deny, or take away. So we're going to deny, and left or right, 192.168.1.2. So it's host. Oh no, not yet. So it's deny any IP from host 192.168.1.2 to, let's go any, because it's fine. We've not applied this yet, so it's fine. And then permit IP any. So what we've done is denied that one host on the left that's currently pinging from accessing anywhere, and we're going to apply it closest to the source as well. So what we're going to do is go. I'm going to bring up the other ping at the same time actually. So we've got the other ping going. We should just see one of them drop off when we apply this. We might struggle applying it because normally the rule is as well 1 ACL per direction per port, and we've already got one going in for gig 0/0.10. But anyway, we'll apply it. So I'll go int gig 0/0.10. Let's see if we can cope with more than one ACL on an interface. And then IP access group. The word stop DC, then direction in. Nice. Look at that. Look at that. Got one denied and one permitted because of ACLs. We can also control things like SSH, because you can block 22, port 22 as well, and it'll also, you can use common words within that, but I'll let you play all you want with that. Cool, so that's ACLs. What we're going to quickly do, I think, is set up this for at least pinging its own default gateway with regards to IPv6, just so we can see it done practically. I know I did it theory-wise, but I want to really prove it. So I'm just going to set up this client here with IPv6 address. It does do it. Cool, and you can even see here that we can run IPv4 and IPv6 together, and this is also known as dual stacking. So we can run them. We can run almost two separate infrastructures. And what you can do is overrun it. So you can have this IPv4, a segment overlapping, and then run the rest of the IPv6 to translate it. It's actually pretty good. So 2001::1. And as I said, it's commonly /64 is the start of the benchmark. So that's what I'm going to do. I'm just going to leave it like that. So that's our IP address, our IPv6 address, and we've hidden the rest of the zeros. So we've substituted them out, and that I'm just going to put this. There's a couple of commands with regards to Cisco to get IPv6 working, and let's see if we can do it. I can just about see it. So it's IPv6 unicast routing. So that's suddenly made it use IPv6. If I do exit and show IPv6 interface brief, here we go. Cool. So we can now actually see a little bit more. We've done that. Turned it on. There is another command, I'm sure there is. I'm just going to set an IP address on gig 0/0.10. So int conft int gig 0/0.10 IPv6 address 2001::. Should we go for max ff /64? So it works for slash notation. No shut, and let's see if I can ping that from the client. So this is just working practically with IPv4 addresses, IPv6 addresses, sorry. So I'm just going to do ipconfig. Should be able to see my link local address there, and I should be able to see my link local. Did I even configure it? Hold on. Interface. Configuration. So that's default gateways. I don't want to configure /64. Done. Let's see what the desktop says. So ping 201::1. So that's itself. No, there is no gateway set. So that's it pinging itself. Remember before we said ping 127.0.0.1 was loopback to ping the IP stack, to prove the IP stack. If I do ::1, that's also the IPv6 equivalent. So what I want to do is ping ff here. So that's pinging that router's IPv6 address, which is good. Cool. So that's sort of very low level IPv6 addressing scheme. We said ff was the maximum value within that section. Cool. I'm just going to get back to the PowerPoint. We'll cover off the last few bits and then we're away. Cool. Cool. So just covering off on the PowerPoint, we've covered Inter-Vlan routing, so route on a switch. That was the sub interfaces with we did it with VLAN 10. We've covered first off redundancy protocol for Hslp, and that was the only one we could set up on Cisco Packet Tracer, but the rest are very similar and quite easy really. We've done static default routes. We've done internal dynamic routing protocols, so VRrp Ospf, Open Shortest Path First, and Eigrp. We did a quick look into BGP, as in just an awareness to say that one was what the internet uses for routing, and that is the external. Using a lot more, it uses autonomous system areas for routing, and also we extended a little bit of knowledge on Ospf with regards to multi-area Ospf, and also spoke about neighbour relationships and solve those states. We looked at PPP and CHAP, and this is what your home Wi-Fi connection uses, because it uses something called Metro Ethernet. So these technologies are still used within that, even though you might not use serial ports, but you still use your clock rates, PPP, and you still use challenge and reply, challenge handshake authentication protocol for that. So you can't plug another home hub in, or you can't randomly create a rogue point through. We looked at NAT, and we configured PAT, and the key command was show IP NAT translations. We spoke about dynamic, and we spoke about static. From normally that's from outside in to allow people in. And we've gone through some troubleshooting commands as well, and we've done some live while we've been at it. So Windows, ping, traceroute, ARP-A, and netstats, Cisco is show IP and brief and show run, and all the other show commands we've gone through. And we've done it during the live demonstration, so it's been quite good. This is generally what we've covered, and I've enjoyed myself, and I hope you have as well. So if you've got any questions, please get back to me on Discord or whatever methods. Thanks very much.